Good morning. Welcome back to the morning show. It's Wise Guy Wednesday. It's also Dr. Z Day. We're kind of combining the two into one fun-filled package, and we're talking about ultrasound.
That's right. And before we lunge into ultrasound, let me mention that this weekend at the U of I is Engineering Open House, which is something that everybody should check out. It's all day Friday and Saturday, and everywhere on the engineering campus you can go and see very interesting demonstrations and so on. And if you go to the physics building, Loomis Lab, which is on the corner of Goodwin and Green, you'll be able to see all kinds of neat physics demonstrations, and it's really worthwhile.
Cool. So check it out this weekend.
Right.
If you're going to be over that way for the WCIA 3 Home and Garden Show, you're going to be in the neighborhood anyway. Now, you've brought the equipment, ultrasound equipment that's used every day in medicine, and you're going to explain how it works.
Exactly right. And so it all works on the principle of sound waves, and that sound waves are reflected from things which tend to be more dense and so on than the other stuff in your body. Your body is mostly water, and so sound travels very well through water. And if you would hold on to the end of this slinky, we can use a slinky to illustrate every physics principle. You might have noticed that.
I thought it was a toy.
Yeah, so if these are a row of water molecules here, a sound wave is a compression wave, and if I send a compression wave down the slinky, you'll notice it bounces off his hand. Okay, and it comes back. And so the ultrasound works in the same way. You send a ping in, a little sound in through a transducer that's sent into your body, and then you listen and you see how long it takes for the sounds to come back and where they come from and so on, and you can form an image. And
you can plug in for my area here. That's also the way weather radar works.
That's right, and we're going to talk about weather next week, aren't we?
Yeah.
Okay. And so normal sound sounds like this. That very annoying tone is A, which is 440 hertz. The ultrasound runs at several megahertz, so it's many, many thousands of times higher frequency. You can't hear it at all. The wavelength for this sound is about a meter. The wavelength for the ultrasound sounds is less than a millimeter, a fraction of a millimeter, so you get very high spatial resolution when you do these things. And what he's about to show you is ultrasound that works on the principle of Doppler shifting, which is that when you have a moving, when sound waves bounce off something that's moving, it shifts their frequency a tiny little bit. And I have a demo for that right here. I'm going to use this annoying sound in a shopping bag. I'm going to spin this thing around.
I thought physics was so high-tech.
Oh, yes, it is. This is very high-tech. Come on. So I'm going to put this in here and spin this around. Now, if you listen, you might have heard there. Okay, shut up. You might have heard
kind of surging.
The sound as it came toward you, the pitch rose a little bit. As the thing was moving away from you, the pitch dropped a little bit. That is Doppler, and it's the same principle that this thing works on. So why doesn't Dr. Z grease you up and check your pulse rate here? So what he's going to do right now is he's going to put on some jelly onto your wrist, and that's going to allow a very good acoustical connection between the transducer, which is this black thing he's going to put on there, and your skin.
I was wondering why we use the jelly on these things. It just kind of makes a better
It just makes a nice connection and gets the sound into your body. And now he's going to put that on there. Can you hold it up to your microphone?
Yeah, it's kind of hard to hear. So I am alive.
Yeah. We have a good, strong heartbeat.
Okay. Is he pregnant?
I can't tell right now.
Let's get another view from this side.
Right. And so the way this thing works is it actually, as the blood flows through the vein, as it goes by just underneath that transducer, it actually, the ultrasound goes in, the little pings go in, and they bounce off something that's moving, which is your blood.
Cells.
And
as the blood comes toward you,
yes,
you hear the sound wave, and as it leaves, the sound wave disappears.
Right, and so that changes the pitch, and that means the thing can pick it up.
So we combine physics and medicine in one package today. Guys, thanks for coming in, and thanks for letting me know that I am actually living this morning. Next week we do weather with the Wise Guy. If you have questions for him, you can link to his website from ours, wcia.com. We'll be right back.